So I'm going to be going over like one example problem per section, and I'm going to show you what that example problem helps you with, so that way we can get through this entire thing. So the first thing that we got is the average weight of a pig is 100 pounds with a standard deviation of 15 pounds. If I think it says Wilbur, sorry. If Wilbur weighs 120 pounds, what percentage of pigs weigh more than him? So what we're going to have to do here is we're going to have to use our formula in order to actually find, first, how many standard deviations he is away from the mean. And then with that, we're able to find the percentile and so on and so forth. All right, so let's start with figuring out a couple different things. First, we know the standard deviation is 15 pounds. We know that the mean is 100 pounds. And we know X, which is the Wilbur, is 120 pounds. And remember, the formula for defined a, what is it called? Standard deviation, or how many standard deviations, or the z-score of something, is always x minus the mean divided by the standard deviation. So what we're going to do is we're going to take 120, we're going to subtract the mean, which is 100, and we're going to divide by 15. Okay? Now if we put this in our calculator, make sure you guys always put this in parentheses, because the calculator doesn't understand what you're trying to say. It just understands what you put in. And so in order to do this correctly, you always have to put that part in parentheses. And I get the z-score of 1.33. So at this point, what I'm going to do is I'm going to actually look at my z-chart. Now, I'm going to look for 1.33, and since 1.33 is positive, I'm going to look on this side. I'm going to look for 1.3, which is right here, and then I'm going to go over until I get to 0.03, which is right here. So this is the number I want. That means Wilbur is in the 0.9082 percentile, okay? 0.9082. Now, what we're going to do now is we're going to figure out what percentage is more than him, because what this percentage is saying is that Wilbur is in the technically, remember, first I'm going to convert this into a, what is it called, percentage, to show you what the percentage is, and just to explain something for you. So we know that whenever you have a decimal, if you multiply that by 100, that gives you your percentage. So this is going to be 90.82. So what that means is that Wilbur is bigger than 90.82% of all pigs. But what we're trying to do is figure out what percentage are bigger than him. So remember, we can either use this number or this number. Okay? When you have it in decimal form, what you do is you always take 1 minus. If you have it in percentage form, it's 100 minus. It's going to come out with the same thing, just in two different forms. So I'm going to do the 100 minus and the 1 minus just to show you what the difference is. And this gives me 0.0918 or 9.18%. Okay? So what that means is that 9.18% of all the pigs weigh more than Wilbur, okay? So that's how you always find more than, is you always have to figure out what the actual percentile is, and then subtract that from 100 to find more than. If it was looking for less than, then we would say 90.82% of pigs are less than him, but since it's more than, we look at the ability to subtract. Now, this problem is going to help us with 1, 2, 3, and 4. Okay? Now, this next problem is a little bit harder, and it uses a little bit different formula. It actually rearranges this formula. Okay? So what we're trying to do is we're trying to find, using the percentiles, first going to find the z-score. We're going to multiply that by the standard deviation, and then we're going to add the mean to that. Okay, so that's what we're going to do. It says, a company claims it can get your weight in the 45th to 60th percentiles. Okay, if the average weight is 140 with a standard deviation of 10 pounds, find the range. So what we're going to have to do is we're going to have to figure out what the 45th percentile is and what the 60th percentile is in terms of standard deviation. So we know this 45th percentile just means 45%, and the 60th percentile just means 60%. So now we need to get it from this form into this form. And remember, in order to get it from this form into this form, we had to multiply by 100. So to do the opposite, we'd have to divide by 100. So we're going to divide by 100 here. That gives me 0.45. I'm going to divide by 100 here. That gives me 0.60. From here, I need to go back to my z-score chart. Okay. So first, I'm going to look up 0.45. All right. Now, so 0.45 is not a z-score yet. It's still a percentile. So these outer numbers, remember, are These outer numbers are z-scores. It's these inner numbers right here. It's the inside numbers that are percentiles. So what I'm going to first look for is 0.45, or at least the closest thing I can get to 0.45. Well, the smallest thing I can get on this side is 0.500, so I'm going to flip it over. I'm going to look for 0.45. So I'm going to go down this until I get to something. Okay, so now I know it's 0.45, and it says 62, 0.4522, 0.4483. So it's somewhere in between this. Okay, so I need to figure out what's closer to 0.45. So in order to figure that out, I'm going to take my handy calculator. I'm going to take 0.45, and I'm going to subtract this one. That's going to give me 0.4522, and it shows me a difference of about 0.0022. Now I'm going to do the same thing with this other one. So it's going to be 0.45 minus 0.4483. It gives me a difference of 0.0017. So we want the one that's the smaller difference. Is this one or this one the smaller difference? Well, it should be the second one is the smaller difference. So since we use 0.4483, that means that's the number we want to use. Okay. So now we need to find our z-score. So it starts off with negative 0.1. Okay, so negative 0.1. And then we go up to the top, 3. So negative. So this one is negative 0.13. And that's its z-score. We're going to do the same thing with 0.60. We've got to find this on our chart. So I start looking for it. I start seeing these numbers until I get to right here. It looks like it changes from 0.60 to 0.59. So that means that it's in between here somewhere. So I'm going to do that whole thing again. Figure out what's the smaller difference. So I'm going to take 0.60 and I'm going to subtract 0.5987. That gives me 0.003. I'm going to do the same thing except for with the other one, minus 0.6026. And you can tell that the 0.13 is closer than the 0.0026. So what we're going to say is that this top one, or 0.5987, is the one we're looking for. So I'm just going to look at that. The z-score is 0.25. So 0.25. 0.25. And those are my z-scores. And now I can plug this into the formula. My first z-score is negative 0.13. I multiply that by the standard deviation, which is 10 in this case, and I add the mean, which is 140. So I take negative 0.13. I multiply that by 10, and then I add 140, and I get 138.7. And I'm going to do the same thing with this side. So that'll be 0.25 times 10 plus 140. So 0.25 times 10 plus 140. That gives me 142.5. So that means the range in which this company is claiming that it'll get you into the weight is between 138.7 pounds and 142.5 pounds. Okay? Now, this will help you with five, 6, 7. And that's it. And that's it for this chapter. So if you need help, again, I will be back on to